So Edipo is going to start off with, and it's really not an application, it's the complement of the application on the ground, and I think there'll be some interest here in terms of people using Cosmos, but they've been working on, or they have, a CFDP engine for Cosmos, and I think it's written all in Ruby, but we'll find out the details. All right, thank you.
You can see in the title there.
Yes. So there it is. Oh, pure Ruby. I didn't finish the title.
Good afternoon. So this is the agenda that I'll follow in this presentation. I start talking about the motivation that led us to build this engine, and then explain how it works, which are the fine detail there, and our test procedures related to it. So I'm from a company in Brazil named Visiona that is part owned by Embraer and part owned by Telebrás. We have around 60 employees, and half of those are engineers, and we have 3 of those allocated in our projects of flight software and ground software. Our main project until now was the SGDC, Geotelecom Satellite. And we have this internal project of tech demonstration that we call it VCUB1. And the idea is to validate our software developments to be able to, in a long term, have a small platform with this technology. We choose to use CFS Cosmos in our environment because of all the things that let you also use it. Heritage, open source, modularity and flexibility. And you can use both tools in the whole process of development with small changes. Okay, so come back here a little bit. So when we tried to use Cosmos with CFS, we had a good integration between telemetry and telecommands. But as CFS relies on a file system and file exchange to update code and tables, we saw that this feature was missing in the Cosmos, and that's why we decided to implement this CFDP engine, so we can update tables and change software in a production environment. So what this engine does? It implements class 1 and 2 file transfer for the CFDP protocol. That is the transfer point-to-point without a proxy in the middle of the transaction. Uplink and downlink. Immediate mode, we have some 2 or 3 different modes, but this one is the one that is implemented in the other side. That is the application of the CFS file. I'm sorry. The application that transfers the file is CF. CF. I'm sorry. We have also used indication about the transaction that goes on, transactions log, and we integrate the functional test of our engine with the test run of Cosmos. We have some limitations, like message to user. They are defined in the protocol, and file store requests are also defined, but they are not implemented in our engine, neither in the CF, because in both cases we have other applications that do this kind of thing. This file store requests, they are done by FM, and message to user by a telemetry downlink application. CRC is not implemented in CF also, so we did not do it in our end. Of course, the engine must work with Cosmos, and some configurations values were set to match CF configuration. They are not defined in the protocol, but they are easy to change in the engine. So if for some reason you have another endpoint that does not use these lengths, you can easily change that. So in our scenario, we have the Cosmos, that the spacecraft, and the CFDP engine. The PDUs are communication between the CFDP engine and the spacecraft, and both talks with Cosmos through telecommands and telemetries. Our engine, it has 4 entry points. The cycle timeout, the pop buffer, uplink request, handle PDU received. The handle PDU received, it handles PDUs that are coming in the engine, of course. And for both classes. And the uplink request, it is a Cosmos command where it starts to processing a file to generate PDUs to be sent to the satellite. The pop buffer is the function where we empty the buffer to send PDUs back to the satellite. And the cycle timeout, it handles time events, as its type says, because in class 2, where we have some kind of back and forth interaction, these timeouts are very important. So our engine, we have 3 commands to interact with it in the Cosmos. We have a send file, a set sequence number, a request, and we have 3 ways to see what it does. Housekeep package, the files that it generates, of course, and the logs that it creates. For the test of our engine, there was need to create one CFDP test protocol. I don't know how familiar you are with Cosmos, but now Cosmos allows us to create stacks of protocols inside one interface. And adding a last protocol in this stack, we can lose incoming or outgoing PDUs without the upper layers knowing what's happening. So this layer sends some PDUs to the spacecraft, and this layer can just choose to not to send that, as some PDUs come from the spacecraft, and this layer can just choose not to give to this one. Another small detail is that this layer, it does not only reroutes the PDU. It copies the PDU to the CFDP engine and gives it back to Cosmos so it can update its counters. So you can always see through the default interface how much PDUs were sent, how much data was sent. And your PDU is processed here without a problem, that way. So what this CFDP protocol does, it simulates loss of packets sent, loss of packets received, and you can control it through Cosmos commands, specify the the class of the package that you want, and the order it appears in the connection to be lost. You can see this better in the demonstration that I will give after that. So for the test of our engine, we implemented the functional tests in Cosmos. We test everything from class 1 and 2, uplink and downlink. We have one test for each kind of message exchange to be lost, so we can try to so you can see if the connection persists. We have configuration files to set file size, directories, and IPs. All the test inputs are saved in one folder. So every test, even the random ones, they can be replayed anytime you want. So you can run one test all night, and just one fail, you can go back there and play it again and see what's happening. So the engine is distributed in an open source way and the GPL v3 license because of Cosmos that is distributed like that. This is the address in GitHub. It's empty right now, so don't try to access because our validation process took a little bit too much. But I'll try to give you until the end of the week. And we are open to community contributions. So we expect you to use it and to find problems and help us to have a better engine to all of us. So we understand that the CFS is a community collaboration, and all of us gain something when we give back to the community. So we are willing to collaborate. And if everything is okay, we'll give you a rubbish engine to be easy to install. And I would like to give special thanks to you that help us this year, and also Susan that is not here, and the people in Bau Aerospace that contribute with our development through the year. This is my contact, and that's it.
So you know UCRC, do you have some other way of determining integrity?
Good question. Actually, the protocol gives you some other ways to check your information. One of those is the file size that goes in the first package that you send, the metadata package, and there is also the consistency of the frame that is sent from the CFS. So we know that our frame is consistent, and one of our choices was to have only one telemetry per frame. I'm sorry. So we can almost guarantee that what you get is what was sent. Yes.
The link between the spacecraft and the CFDP engine, is that TCP/IP or?
Yeah, it's UDP like the default of Cosmos, and what we do is we get the default Cosmos interface, and we create a new one extending that interface where we can add protocols. So we add our CFDP protocol, and then we add the test. But of course, in in production, we will not have this test one because we don't want to lose any packages.
Okay, but you could use you had a different uplink and downlink interface.
Yes, of course, of course. If you had serial, for example, you can use that because, as I said, the interface between the engine and the Cosmos is done through this protocol that is actually new. I believe it's in the 4.0.0 version that they introduced. So it's very easy to have communication protocols that are not related with the transport layer. So you can have a serial connection and process through these protocols. They only see stream of bits and packages.
Okay.
So you have two levels of these protocols, and they don't care about the transmission layer.
That's a great contribution.
Thank you.
Did you look into framing also, like a TMSDLP protocol and that sort of thing?
Framing
Framing
of, I'm sorry.
of packets.
Yes, actually, we had that implemented in our in the Cosmos. We have copy 1 and CL2.
Oh, you do?
Yes, we had that.
Are you planning to release that also? Or?
I don't know if you want. So
Historically, that's been one of the limitations of Cosmos, is that it had been primarily a packet interface.
yeah, we had that idea when we start to work with, but this version 4 is very. It seems to be thought to use in a more I don't know how to say it, but in the right way, let's say that. But it's very good. The version 4, it was a big step up.
To do frames.
Yes, that's the point. The interface does not need to know what it gets, as long as in the end of the protocol it has the package that it assumes that you get. So you can put all your frames and all your protocols there, and in the end you can. The Cosmos can work as it works, thinking about packages. Okay.
Is it a single transaction, or can you have multiple transactions?
Multiple transactions. The limitation is your RAM in your disk space. So.
All right, thank you.
Thank you.